this lesson, we're going to take a look to high-level and low-level language translators. That is, we're going to take a look to compilers and interpreters. The learning outcomes of this lesson is, we're going to do a small recap on what we have studied in the previous lesson. We're going to take a look at some of the evaluation exercises related to previous lesson, and then we're going to take a look to the differences between compilers and interpreters. So a small recap, we have seen different levels of languages, starting with the machine code, which is closer to the hardware level and is usually 0101, which is a binary number. Next, we have the low-level language, who includes a little of English keywords or mnemonics. And at the much higher level, we have high-level language, which is closer to human-level languages. So as we move down from higher level language to machine code, we're going to get closer to machine code. As we move from the bottom level of this diagram to the upper level, we're going to go closer to human languages. Okay, the first exercise. Study the following three sections of code. As you can see, we have three code snippets here, A, B, and C. A is made up of a series of binary numbers, 101, 01101. B is made up of mnemonics, short keyword, English keywords. C, we have a for loop from our paper 2 concept. Now we are supposed to identify using letters A, B, or C which of the following above code is an example of assembly code, high-level language code, or machine code. Now, the first one is assembly code. To find out which of the following here is an assembly code is made up of mnemonics. So we know that B contains mnemonics. High-level language code must be a programming language or some form of pseudocode here, which is written. So for x is equal to 1 to 10, written, and 4. So C is a high-level language. And machine code, it must be in binary format. So for it's A. So finally, the answers for the exercises are as follows. Why do we need translators? In real life, a translator is needed to help someone understand a foreign language. For example, someone understands English only, and one person is talking in French. So we will need a translator, a person who will translate French to English, so that the other person can understand. It's same as Google Translate, where you input a certain keywords and then it is translated to other languages. Now when we speak of translators in this particular topic, we're speaking about conversion between an HLL to LLL, or to an assembly language, or an assembly language to a low-level language, and back to a high-level language. As such, programs are written by humans in a form that people who are trained as computer programmers can understand. In order to be used by a computer, programs need to be translated into a binary instruction or machine code so that the computer understands. When you have written a given particular line of code in any given programming language, it will need to be converted to a series of zeros and ones, as a computer understands only binary instruction. As such, there is a need for translators. Humans find it very difficult to read binary. Hexadecimal is easier to understand, and computers can only perform operations written in binary. Now the first type of translator is a compiler. A compiler is a computer program that translates a program written in a high-level language into machine code so that it can be directly used by a computer to perform a required task. As such, a compiler takes a high-level language code and convert it into machine code. Once a program is compiled, the machine code can be used again and again to perform the same task without recompilation. Source code is converted to an object code or an executable file. With compilers, the whole program itself is compiled and converted into an object code or an object file known as an executable file. The translator or the compiler is not needed when the file will be executed again. That is when the object code will be run. This is a high-level language written. So when it is converted into machine code, we're going to have a series of binary integer values. So this is one of the main functions of a given translator. Now, an interpreter is different from a compiler. An interpreter is a translator program that reads a statement from a program. It reads line by line. It takes the action specified and then does the same with the next statement and so on. It executes line by line. Compared to a compiler which converts whole source code into an object file, the interpreter is going to execute line by line and stops when an error occurs due to syntax error. Maybe the program line is incorrectly written. Now, let's take a look to a quick exercise. State whether the following statements are related to compiler or interpreter. Executes line by line, creates an object code, recompilation not needed once programming code has been converted to machine code. So these are the answers to this exercise. Executes line by line is an interpreter. Creates an object code is a compiler. Recompilation not needed once programming codes have been converted to machine code is a compiler. There is no need for the translator to be present when the executable file is being run. Let's come to assembler. An assembler is a computer program that translates a program written in an assembly language into machine code, so that can be directly used by a computer to perform a required task. Once a program is assembled, the machine code can be used again and again to perform the task without reassembly. Now, an assembler is another type of translator that takes an assembly language and converts it into machine code. Now, you need to remember the differences for exam. Compiler, it translates a high-level language program code into machine code, whereas interpreter, it does it line by line. Execute a high-level programming language into machine code, but it does it line by line. Assembler takes assembly language, or we can say a low-level language, into machine code. An executable file is produced in compiler. No executable file or machine code is produced using an interpreter. Using an assembler, an executable file is produced, since we don't need the assembler or the translator there. One high-level language statement can be translated into several machine code instructions using a compiler. An interpreter, one high-level language program statement may require several machine code instructions to be executed. An assembler, one low-level language statement is usually translated into one machine code instruction. For a compiler, compiled programs are used without the compiler. Interpreted programs cannot be used without the interpreter. There is need for the interpreter to be present. Assembled programs can be used without the assembler. For assembler, a compiled program is usually distributed for general use. An interpreter is often used when a program is being developed for finding bugs and so on. An assembled program is usually distributed for general use. Let's take a look to a quick evaluation exercise. You have a series of statements here. You have to say whether it is related to interpreter or compiler. Creates an executable file that runs directly on the computer. More likely to crash the computer since the machine code produced runs directly on the processor. Easier to debug since each line of code is analyzed and checked before being executed. Slow speed execution. More difficult to modify since it is in machine code format. So these are the answers for 5 marks. The first one, since we have the keyword executable file, it is related to compilers and more likely to crash because there's already the machine code present, full of them. Okay, or the source code has been converted into machine code. So this is compiler. Easier to debug. We know that for debugging we use interpreter. Slow speed of execution of program loops. In a loop, an interpreter executes much slower, so it's an interpreter. It is more difficult to modify the code since the executable code is now in machine code format. That's for a compiler.